Today we are just going to discuss cylinders, cones, spheres, and pyramids, and how to recognize them, what shapes create them. So to recognize a cylinder, first of all, think of a soup can or a soda can. A solid cylinder has a curved surface and two parallel bases. These bases are congruent circles. And we must remember that congruent means the same size. The radius of a cylinder is the radius of one of its bases. So if I look here, I look at one of the bases. Remember, a radius goes from the center to the outside edge. The height is the perpendicular distance between the parallel bases. So it has to be straight up and down or hit it at a 90 degrees. So if the cylinder is turned on its side, it's actually from one end to the other. Okay, the net of a cylinder then, remember it's made up of that round surface. That round surface, when you actually take it apart, is a rectangle. So if you split it open and cut it apart, it would be a rectangle. And then the bases are those congruent circles. So yours are probably going to look a little better than mine, but they need to look like they are congruent. So that makes the net of the circle created up of two congruent circles and one rectangle. Okay, if we go ahead and we turn our page, a cone now. Think of an ice cream cone, or a party hat is what this looks like since it's setting this way. The height of the cone is the distance from its vertex to the center of its base. And you notice it's also perpendicular. Height is always represented with a perpendicular height. So the height of the cone goes from vertex, there we go, to center of the base. Okay, I just said a normal height would be perpendicular to the base. Well, the next thing we're going to discuss is slant height, and it's exactly like what it sounds like. The slant height is at a slant. So it goes from the vertex to a point that's on the circular base. So the slant height is from the vertex, so it's at a slant. That's why it's called the slant height. Vertex to point on circle. The following thing, the lateral surface then is a surface that is not the base. So our base here is a circle, so the curved surface then is called our lateral surface. The net of a cone then, obviously it has the circular base. And then when you take this and let's say you cut it up a side and open it up, it has to have this curved base that actually wraps around the circle. And then it comes up to a point. Remember, I'm a math teacher and not an art teacher. So that is how you would recognize a cone. Our next one we're going to talk about is a sphere. A sphere is probably one of the most well-known ones because they are represented baseball, basketball, any of those kind of things. It has a curved surface, obviously, and every part is equal distance from the center of it. So the radius then goes from the center to any point on that curved surface. So all of these would represent a radius. Okay, so distance from the center to any point on the surface. Okay, the next thing is a hemisphere. Hemisphere is just basically when you cut the sphere in half, it makes two hemispheres. I'm going to go ahead and turn our page once again. And now we're going to talk about cross sections. Well, cross sections are basically if you take a solid and you cut it. Okay, it could be cut directly in the middle, kind of like this one. But it doesn't have to be. Anywhere that you could cut it, you could cut a corner off of it. Whatever part's cut off, it creates a cross section. So a cross section is created when you slice a solid. So if you slice a solid, you're going to create a cross section. And that's the shape that's created when you cut it apart. The plane is what they call the flat surface that is actually cutting it. So if I look here, if I cut this, and this is a cube, we want to know, what does the cross section look like? Well, the cross section here is represented in green. So if I look there, that cross section is actually going to be creating a square. It just depends on where you cut it. If I look at the next one, we have to remember how to name these as well. This comes to a point, so it's a pyramid. The base is a square, so this is a square pyramid. And I said you could cut them anywhere you want. So if I look at this one, they chose to cut it horizontally. So if they cut it horizontally, it actually created a cross section of a square as well. Well, down below here, they're going to take the same square pyramid, but this time they cut it vertically. So if they cut it vertically, it actually creates a triangle cross section. So you just need to be able to name the shape of the cross sections once they are cut. Remember, the plane is what cuts them. And now to name a prism versus pyramid. Sometimes this is confusing for people how to tell the difference. Well, a pyramid comes to a point. That point is called an apex. So if it comes to a point, that means it only has one base. It's called a pyramid. So this would be a triangular pyramid because the base is a triangle. This one would be a square pyramid because the base is a square. The prism has two bases that are connected by the sides. Remember, we always name a prism or a pyramid by the base shape. That's what we just did, naming those pyramids. So if I look here, this base has 1, 2, 3, 4, 5, 6, 7 sides. Well, a 7-sided polygon is a heptagon. So this is a heptagonal, and it doesn't come to a point. It has two bases, so it's a prism. If I look at this next one, my bases, there's a base and here's a base. It doesn't come to a point, so it's a prism. The shape of that base is a triangle, so it's a triangular prism. Go ahead and you need a pause so that you can do guided practice, page 129, 1 through 4. And then your homework assignment that matches with this is page 130 through 132, 1 through 16.